All right, hey guys, how's it going? Happy Monday. Hopefully you had a fantastic weekend. And hopefully today's going well. I apologize that this video is just going to be of you staring at a screen and my voice. I'm trying to find a program where you can see my little face up here. But we are just going to cruise through these notes, and you guys are going to be working on some graphing here today, okay? So let's talk a little bit about graphing. You guys should have your graphing notes. At any point in time, you can hit pause on this video if you need to record something down or whatever. Okay, so again, feel free to hit pause at any point in time. All right. So, what are some different type of graphs? This isn't actually not on your notes, but it was one that I would talk about if you guys were here. Probably what you guys are most familiar with are the bar graph, the line graph, a curve graph. Today, you're actually going to kind of play with the line graphs here as far as graphing. But in the activity that you guys are going to do, you're going to be interpreting bar graphs, pie graphs, and then obviously line graphs. Okay, but for anything that I ask you to graph, it's pretty much 9 times out of 10 going to be a line graph. Okay, all right, so what is a graph? It's basically going to be a diagram showing the relationships between two variables, okay? It could be more than that, but typically it's just going to be two basic variables. What's cool about graphs is that it actually takes all these numbers that you have and they put it into, I guess you can say, a story. It's a picture that tells a story. If we were to graph your bubblegum data, the best graph for that one would have been a bar graph. And that's just kind of in your face, very easy data. You would have noticed that the Hubba Bubba had the largest mass and the biggest bubbles. If you look right here, if you notice the population of bears, that's what this graph is showing right here, is that throughout the years, the population graph, the number of bears increased and then decreased dramatically. Kind of fluctuates, I guess you can say. Okay, so a diagram showing the relationship between two variables. Okay. All right, so how are we going to graph? What I'm going to get you guys to do is you guys actually have a stapled sheet of paper. If you can tear off that back piece of graph paper for me, please. Okay, just kind of separate those. All right, and then if you flip your notes over to the back, you should notice that there's two sets of data there. Okay, one that deals with tadpoles, another one that deals with diameter of trees. We're going to kind of do a graph as we take these notes. And like I said, some of you guys could be professionals at graphing, but again, I want to make sure that we're all kind of on the same page. Okay? All right, so the first thing that we want to do here for A is that we want to identify the variables. Okay? Now, this is stuff that we talked about on Friday. All right, so in identifying the variables, you got to figure out what the independent and the dependent variable is. Now, I know that you guys had homework, and the sub did not go over that with you guys, but when I get back on Wednesday, we'll spend a little bit of time discussing those results, okay? So the dependent, what is measured, the independent, what is varied, or what is changed. You don't necessarily have to put down what dependent and independent is because you've already written that down, okay? All right, so let's look at the chart that you have there for the pH of the water, and the number of tadpoles. All right, what you guys are going to do with this data is you're going to figure out which one's the dependent, which one is the independent. So what we're measuring is basically we're measuring the number of tadpoles. Okay, and the independent is going to be the pH of the water. All right, now I didn't really give you a phrase for that one, but this again, we're just kind of briefly going over that. Okay, all right, so you're going to identify the variables. All right. Second thing that you want to do is you want to label your axes, okay? And I'm going to kind of walk you through as far as how you do that. So for letter B, let's put down label your axes, okay? Now I definitely would put down both of these things right here. That's your dependent variable, and you guys can abbreviate that by saying dv if you would like. Your dependent variable will go on the y-axis, while your independent will go on the x-axis. This is a huge mistake that people always make, is that they kind of get that mixed up quite often, okay? I heard my colleague, Miss Freeman, telling her kids that the independent is 4 syllables, so is the horizontal, and that's basically this one. This is horizontal, so independent, horizontal, goes on the x, okay? Let's say that you can't remember that. Kind of my cheat that I give you guys oftentimes is that if I were to give you a data table, all right, usually I'm going to say 9 times out of 10 what you're going to find is this first column of data, like pH, that will always be the x-axis, and the second one's the y, okay? For everything that I'm giving you, that's going to be the case. So the first set of numbers is the x, and the second number is y. We just got to make sure that we understand which one is the x-axis and which one is the y. Okay? All right, so what I'd like for you guys to do right now is let's get your graph paper. Okay, and I want you guys to fold it hamburger style. What I mean by hamburger style is basically there's hamburger and hot dog. Okay, so you guys can fold it two ways, and if one looks like a hot dog, then you need to fold it the other way. Okay, so you're going to fold it in half hamburger style, and we're just going to do a graph on one side of it. Okay. What I would also recommend is doing this in a pencil, okay? Because if you make mistakes, you don't necessarily have any more graph paper. I forgot to leave some for the sub, so borrow a pencil from somebody. You can hit pause and do that, but pencil's kind of a big thing. The other thing I'm going to ask you guys to do is to hit pause and actually go get a ruler. The rulers are located on, you know, where you turn things in on the side of the classroom. You'll see a bin there that has rulers. Okay, so hit pause on this and go get yourself a ruler. Please, if you guys give me jacked up lines on graphs, I am not a happy lady. All right, so hit pause and do that. All right, so let's go ahead and draw in our axes. Okay, so what you guys got right here is you got your y and you got your x. If you guys notice that I want you guys to take up the bulk of the graph paper, okay, on just the half side. You don't have to do the whole sheet. All right, so on one half of that graph, go ahead and draw this great big huge, basically an L. All right, you don't have to give me a plus sign showing the 4 quadrants like you typically do in math. Okay, you're just going to draw a big L. Okay, and I'm making it a little bit bigger than mine. All right. Next, what we're going to do, if you notice, for B, I asked you guys to label your axes. So if you're drawing this, go ahead and hit pause. Okay, go ahead and get that drawn in. All right, when you click unpause, what we're going to do is we're going to label those axes. So the pH of water goes on the X and the number of tadpole goes on the Y. It's extremely important that you label the axes, okay? Because if you don't do that, I don't know what you're graphing, okay? And assume that I know absolutely positively nothing. All right, so go ahead and label those. And again, hit pause because I'm going to keep on cruising. All right, so we've labeled our axes and got our axes drawn using a pencil and using a ruler. All right, so C, this is the part that's probably the trickiest for you guys, is that you're going to determine the axis scale. All right, so that's C. So for C, put down determine the axis scale. And actually, I'm going to have you guys write down a couple of things besides C. Okay, so determine the axis scale. Now, probably one of the biggest misconceptions is that you students think that they need to start, let me back up, right here, that this has got to be 0, okay? It doesn't have to be 0. All right, so please, if you could, besides C, say you don't always have to start from 0. All right, typically what you do in that instance is you find probably one of your lowest data points, okay, and then go down a little bit more, and that's typically where you want to start from. Now, sometimes it does start from 0, okay, and that works out fine, but both of them do not. Okay, so for example, what I mean by that is here we have the number of teens, okay? Here, it made sense to start from 0 with this set of data, but right here, it didn't make sense to start from 0, so they started from 13, okay? Because obviously, a 1-year-old, 0 to 1-year-olds, which would be the age of my daughter, she's not going to be walking around with a cell phone, so why even include that in the data? All right, so if you notice here, they started with 13. All right, if you guys notice how this graph takes up the whole piece, okay? And that's what I want from you guys, is a nice big old graph. I can't stand it when you give me a little tiny little baby graph, okay? So that's C. All right, the other thing I'd like for you guys to write down by C is just say spread out the graph, okay? I want it to take up all the graph paper. Like I said before, I want it nice and big. All right, so spread out that graph, okay? Spread her out, please, okay? All right, so I'm actually going to finish the rest of the notes and then we're going to come back and work in filling in your graph, okay? All right, so what's going to happen next with D is for D, you want to plot your data points. Once you have your axis scale drawn, okay, for D, you want to plot those data points. All right, and they're actually provided in the chart, like what you see right here. Your first point would be 8 and 45, okay, 8 and 45, right? So you're going to plot those data points. Okay. All right. E, you're going to connect the data points using a ruler. All right. And that's why I asked you guys to go get a ruler. Now, a lot of you guys think you're slick, right? And you're like, I'll just draw this line, these lines by hand. I can always tell. All right. And actually, I take off points if you give me a jacked up line. That's just bad science. Okay. So make sure that you always use a ruler. And if I don't provide one for you, you can always get up and go get one on your own. That's not a problem. All right, but you need to make sure that you always use a ruler for that. All right, And last but not least, F, you're going to title your graph, okay? The title doesn't have to be anything fancy. You guys can get creative. I enjoy creative titles because they kind of make me giggle. But like for this particular one, you're graphing pH of water and tadpoles. And you guys could simply say pH of water and tadpoles, or pH effect on tadpoles, or you can get even wackier and say, I don't know, tadpoles on acid. Okay, and that's a really bad example, so you can't take that one. But just something creative that kind of catches me off guard and makes me giggle. Okay, that's always a good time. Okay? All right, so let's hop back to plotting these actual points, okay? Now, we already have our axes labeled, okay? And what you guys are going to do here is that you got to set up your scale. Now, if you check out my pH of water here, you can find your lowest number, okay? My lowest number is 5.5. So probably what I would start off with is I would start off with a data point of 5, okay, on my x-axis, all right? My highest point is 8, and you can take it up to, let's say, 8.5. Now, it'd be silly to go from like 0 to 20, okay, because that kind of defeats the purpose. You want to try to spread it out nice and neat. Now, one thing I want to show you guys, let me come right here. This one's not necessarily skipping any lines, okay? But what you can do is that, let's say that you start right here with a 5, okay? Skip a couple lines, and I don't know how it's going to work. You can try skipping one line and go to your next data point and skip a line and go there. Just kind of pace it out without marking anything down. And if that doesn't work, start here again, okay? And then maybe skip 2 and give me the next one. So maybe 5, skip 2, 5.5, skip 2, 6, next one, 6.5. But if you guys notice, I want it to spread all the way out, okay? I want it to take up this whole line, and hopefully your line's a little bit bigger than mine. Okay, and same thing with the number of tadpoles. You can start right here, skip a line, and it's up to you to figure out what the scale. Now, what's cool about graphs is that I kind of anticipate everybody to have something a little bit different, okay? Nothing really to be the same. Okay, so that's determining your axes. Okay, once you have your scale set up, you're going to plot your points. So your first point is 8 and 45. Okay, then 7.5 and 69, and vice versa, blah, 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 blah. Okay, once you have all that, you're going to draw using a ruler, and you're going to write a title on your graph. Okay, now, before you hit pause and work that one out, I just kind of want to explain a couple more things to you. Okay, so that's this information right here. So once you have all that plotted right there, okay, I do want you guys to go through and answer these questions. Okay, so take a little bit of time, and in order to answer these questions, you got to actually have your graph complete, okay, to answer those. All right. On the other side of that hamburger, you guys are going to do one more graph. Okay, you're going to do another graph. Now it's with this data right here. Now this data looks a little weird, okay, because actually if you notice you got 3 columns here. But what you're going to have is you're actually going to have, and let's see if I can highlight this, okay, you are going to have 2 graphs, okay. You're going to have one set of, one line for this stuff right here, okay? So you're going to find this, you're basically going to plot the age of the tree with the average thickness of forest A, okay? And then you are going to do this data right here and this data right here. Whoops, 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 okay? And that's going to be your next graph. Okay, now because you're going to have 2 lines on that graph, you need to make sure that you give me a key. Okay, saying this line represents forest A, this line represents forest B. You can borrow some colored pencils if you would like. You could do one in pen and one in pencil as far as like tracing the line. It's up to you, okay? But what I would recommend is do that information, draw that line, and then go to your next graph. Okay, so 2 lines on each. Now, one thing that you got to pay attention to is that in coming up with your scale for your y-axis, you need to find your highest and your lowest between these 2 sets of data. Okay, so for example, it looks like my lowest is about 2, and it looks like my highest is about 4.5. Okay. So then you graph that, label your axes, give me a title, give me a key, and answer these questions, okay? Now, one thing I'm asking you guys to turn in today is that you're going to do both of these graphs, and then what I would like for you guys to do is to staple your graph to these notes, all right, to these notes right here, and you're going to turn them into the bin, all right? I want to see what it's kind of like more of like a working notes, okay? So I expect you guys to get done with this today, and I'm going to check out your graphs and see how you guys are doing, okay? If you have any questions at any point in time about anything, okay, you guys can email me. All right, very easy to email me. How you can email me is you just basically go to your Gmail. Oh, shop the look. Hey, get it, Miss Chris, hanging out on the Zoo Lily. Okay, you can go to Gmail. All right, your student mail, you don't necessarily have to do it that way. And when you hit compose, you can actually just type in Christofferson and my email address will pop up, okay? And you can say, Miss Chris, I don't understand what's going on here with this. Please tell me about it. I'm home with my baby, so obviously I can help you if you need help, okay? When I was on maternity leave, I had kids do that all the time, all right? So please feel free to send me questions if you have them, all right? You have a little gizmo that you guys are going to do, all right? The login, the substitute will provide you with the login. You definitely need to make sure that you do log in. All right, and this is just going to be kind of an activity interpreting graphs. I think you guys will kind of enjoy it. These gizmos are pretty awesome. All right, and then you have some homework to do tonight, okay, in interpreting graphs. I do want to show you guys one thing right here, okay, and that's this one right here. This one's pretty fun, okay, it's pretty fun. I'm excited to see how you guys interpret that. Basically, this graph is showing you the age and height of these people, and you got to try to figure out which number is which. All right, so for example, here I have the youngest and the shortest, and everybody seems to forget Gavin. Gavin is who this lady is holding right here. So he's the youngest and the shortest, so he would be number 7. Okay? All right, so just behave yourselves. Holler at me if you have any questions. The same thing goes for tomorrow. And I'll see you guys on Wednesday. Sure, I'm sorry that I'm out. But, you know, being a mama, duty calls. All right. All right, guys, you take care. See you later.